Hello, once again, ladies and gentlemen, and welcome to our virtual classroom. Today, I want to go over lesson number 2-1, starting off something new. We're done with ratios. Now we're talking about prime factorization. Prime factorization, and here looking at the notes, which I do encourage you to copy down if you haven't done so already. I'm not going to go super thoroughly on this, but I do need you to keep some things in mind before we get into some practice problems. The first is the definition of a prime number. All right, a prime number is a number greater than 1, and really I could have put here an integer because it's a number without a decimal value. So a number that is greater than 1, so beginning with number 2, that has exactly 2 factors, 1 and itself. In other words, we're talking about numbers that can only be divided by the numbers 1 and themselves. Here I provided a list in chronological order from least to greatest, from 2 all the way to 31, knowing that there's an infinite number of prime numbers. Okay, I just wrote down the numbers in order from 2 all the way to 31. And if you notice anything about these numbers, is that all of these numbers cannot be divided by anything except for 1 in themselves. Consider the number 13. 13, the factors for 13 are just, well, 1 times 13 is 13, and that's it. That is the same for all of these numbers. The number 3, what gives you 3 when you multiply together? Again, we're only talking about multiplication in this lesson. Well, just 3 times 1, and that's it. 1 times 3, nothing else. Those are prime numbers, ladies and gentlemen. Notice that the number 2 is the smallest prime number, and it's the only even prime number. Meaning that all the other prime numbers, beginning with 3 and onward, are odd. That is because any even number after the number 2 is always divisible by 1 itself and at least the number 2. Consider the number 4. 4 can be divided by 2. The number 6, 6 can be divided by 2. 2 times 3. 8, 8 can be divided by 2. 2 times 4. 10, 10 can be divided by 2. 2 times 5. So any even number can be divided by 2. So that's why no prime numbers are even, meaning they do not end with 0, 2, 4, 6, or 8, except for the number 2. So those are prime numbers, numbers that cannot be divided by anything except for 1 and themselves. Now, the opposite of a prime number is a composite number. And a composite number is a number that is composed of multiple prime numbers or multiple prime factors. Consider the number 9. The number 9 is composed of the numbers 3 and 3. 3 times 3 is equal to 9. The number 12. 12 is 6 times 2. Some of you will say, well, 2 is a prime number, but 6 is not. Well, but 6 can be split into 3 times 2, meaning that 12 is the same thing as 3 times 2 times 2. It's made up of these 3 numbers being multiplied together. 3 times 2 is 6, 6 times 2 is 12, or 2 times 2 is 4, 4 times 3 is 12. So again, a composite number is composed, notice composite, composed of multiple prime factors, So with that in mind, ladies and gentlemen, a prime factorization, as the definition states, if you write that down, and all it's saying is you're taking a number and splitting it up until all you have left are just the prime numbers. For example, and let me just show you how I came up with this, the number 12. I can split the number 12 into the numbers 6 and 2. Notice that I started up here. This is called a factor tree. I have 2 branches. Anytime you have a composite number, you put a branch. You put 2 branches, sorry. So that means that these 2 numbers multiplied together give me 12. Awesome. The only thing is that of these 2 numbers, only 2 is prime. So I'm going to circle it, indicating that I'm done. I cannot split 2 anymore into any other numbers except for 1 and 2. But 6 here, yes, 6 times 2 is 12, but 6 can be split up. It is a composite number, and it can be split into 3 times 2. So instead of a 6, now I have a 3 and a 2, because 3 times 2 is equal to 6, both of which are prime, and that's how I got 3 times 2 times 2. Now, I could have also split 12 into 3 times 4. 12 is the same thing as 3 times 4. So 3 is prime, so I'm going to circle it so that I know that I'm done there. I cannot go any further, but 4 can be further split down into 2 times 2. So as you can see, ladies and gentlemen, the prime factorization of 12 would be, and I'm writing them down in order, 2 times 2 times 3. 2 times 2 times 3. How do I know that that's correct? We'll just multiply them together. 2 times 2, 4, and then 4 times 3 is 12. Another example here could be the number 84. Notice how I've done it several different ways here. 84 can be split into something like 42 times 2. 42 times 2. Or 21 times 4. Or even 12 times 7. Notice that regardless of which way I start, I always end up with the same prime factorization. For example, here, 2 is prime, so I'm going to continue. 42 can be 7 times 6. 7 is prime. I'm done. And 6 can be split into 3 times 2. Now, if I write these down in order from least to greatest, I have a 2 times another 2 times a 3 times a 7. So meaning that the prime factorization of 84 is 2 times 2 times 3 times 7. Or another way to say this is the prime factors that make up 84 are 2, 2, 3, and 7. Yes, 2 2s, 1 3, and a 7. 2 times 2 is 4, 4 times 3 is 12, 12 times 7 is 84. Or the other way around, 7 times 3 is 21, 21 times 2 is 42, 42 times 2 is 84. Either way, I get the same answer. Now, let's see if we can get the same answer doing it the other ways. All right, well, 21 can be split into 7 times 3, both of which are prime. And 4 can be split into 2 times 2, both of which are prime, meaning that my prime factorization is 2 times 2 times 3 times 7. Notice how it's the exact same thing as what I have up here. Over here, 12 is the same thing as 6 times 2. 2 is prime. 6 is 3 times 2, both of which are prime. And again, notice how I get the same 4 numbers, ladies and gentlemen, no matter how I split it. That is a prime factorization, and we're going to be using that moving forward. Going into the assignment, that's really all we're doing today, ladies and gentlemen. You're looking at a prime, at a number, and you're just splitting it into its prime factors. For example, number 14 here and number 1a, 14, I'm going to split it into 2 and 7. That's the only other way that I can split 14, meaning that the prime factorization of 14 is 2 times 7. We're doing that for each of these numbers. Look at letter E, though. We have 84, the one that we just did right now. So if I do that again, 84 is 12 times 7, 7's prime. 12 is 3 and 6. 3 is prime, and 6 is 3 and 2. So the prime factorization of 84 is equal to 2 times 3 times 3 times 7. Now, when I look at the answer choices, 2 times 3, that's 6, 6 times 3. Wait, did I miss something? Oh, I did miss it. See, notice I made a mistake. Because 12 times 4, not 12 times 6. I mean 3 times 6. So that should be 4, and that should be a 2. So it's 2 times 2 times 3 times 7. See, I made a mistake. It happens. 2 times 2, 2 times 2 times 3 times 7. Okay, 2 times 2 is 4, 4 times 3 is 12, and 12 times 7 is 84. So that works. Now, when you look at E, notice that they give you answer choices. They say, which of these is the prime factorization? Well, some people might say, well, oh, 2 times 42, that's 84. Oh, that's the answer. Ladies and gentlemen, that is not the answer, because 42 is not a prime number. It's not prime. Remember, a prime factorization is only the prime factors. If you see a number that is not prime, then that cannot be it. In fact, looking at C, I see a 21. I know 21 is not prime, so that by definition cannot be a prime factorization. So now I'm left between this one and this one. Well, this looks very similar to what I have here. And 2 times 2 is 4, 4 times 3 is 12, 12 times 7 is 84. So that makes total sense. But down here, notice how 2 times 3, that's going to give me 6, 6 times 3, that's going to give me, I can't even think right now, 18, and 18 times 7, I'm not even sure what that gives you. 8 times 7 is 56. 7 plus 5 is 12. That's 126. That's not even equal to 84. Even though all of these are prime, that is not 84. So the only answer that fits is B. Ladies and gentlemen, I hope this wasn't too confusing. I hope you found this video helpful. And otherwise, I expect to see you at tutoring, or please ask me in class. With that in mind, I will see you next time.